In this video, we will learn how to create geometry when starting from a reference image. As an engineer, you will always encounter new challenges. When designing models, there may be some instances where an existing 3D CAD file is not available, and it's necessary to work from a 2D technical drawing. In other cases, we may have to rely on nothing more than pictures to reverse engineer a product. This process can be difficult and time-consuming, but the tools in SpaceClaim can really help speed things up. For this exercise, we'll be using an image to help us create a skateboard deck, then importing the remaining parts of the assembly. The image will have views from several different angles, which we can use to create an accurate reproduction. First, we need to create a rectangle that matches at least one of the desired dimensions of the model. This will be used for scale, since the size of the imported image may not match the actual size of the model. In this case, the width of our rectangle will match the length of the skateboard. The height should leave sufficient room for adjustments. A value approximately 2 times the total height of the board is good. Make a rectangle with dimensions 800 millimeters by 200 millimeters. Now that we have our rectangle, go to the Assembly tab and click the File button to import the image. Set the File Type option to Image Files to locate the picture and load it. Move the image to the desired location and left-click to complete the placement. Once the image file is placed, select it from the structure tree, and in Properties, set the option Keep Aspect Ratio to Yes. This allows us to scale the image evenly in all directions. Scale the image by clicking and dragging one of the blue dots along the border. Focus on one view and adjust the image size until the length of the skateboard body matches the boundaries of the rectangle we created for scale comparison. Move the image into a good position for tracing its outline. A good way to start is by creating a simple outline first, then adding the finer details. Looking at the image, the side view of the skateboard seems like the easiest one to trace, as straight line segments are easier to recreate than arcs. Trace the image outline. Use the sketching tools in SpaceClaim to your advantage. Sketch 3 small lines along the bottom of the profile. Begin with one angled section. When creating the angled lines, keep an eye on the angle dimension. Use your best judgment to select what the angle should be. Here's a hint. It's probably not 159.3 degrees or 21.7 degrees. Don't worry about the intersections. Then, sketch a line along the center. And finally, the opposite angled section. You can press and hold Shift to temporarily release the snap to grid condition. We can use Create Corner to connect the lines once we finish sketching them. Extend the lines past the sides of the rectangle. You can pull the endpoint of the lines or sketch new line segments. Use Offset Curve to create the outline of the top profile of the skateboard using the 3 lines we've just finished sketching. Now, add a radius to the vertices. We'll have to use our best judgment for many of these dimensions. Think about how you would design a model. Would you use many random and arbitrary dimensions, or would you tend to go for symmetry and even uniform numbers whenever possible? If an area you're tracing measures 103 millimeters, but 100 millimeters seems reasonable when compared to the image, use the nicer looking value. Start the line tool. Connect the endpoints of the top and bottom line segments. There should be a gap to the edge of the skateboard drawing. This will create some excess material, but we'll trim this later on. Now, click Trim Away and eliminate the 4 sides of the rectangle. Don't forget the small segments between the top and bottom lines. Then return to 3D mode. Now it's time to create the profile as viewed from the top of the skateboard deck. Use Move to rotate the image 90 degrees. Reorient the view and move the image so the center of the top view is aligned with the profile we just completed. Since it's just a 2D surface being viewed from the side, the profile is just this thin green line. Select the surface from the structure tree and use Pull with Pull Both Sides enabled to extrude the profile beyond the width of the skateboard as shown in the top view. We will cut away the extra material later. Make sure the model is oriented such that the top view is normal to the screen and create a new sketch in this orientation. Since tracing is an inexact science, it's best to eliminate as much uncertainty as possible. We'll use the mirror tool several times in this exercise to ensure consistency. Take a moment to examine the outline of the skateboard when viewed from the top. The nose and tail are primarily made up of arcs, and the middle segment of the board can be defined with 2 parallel lines. The transition from middle to nose or tail is the portion that requires the most precision. Therefore, we should leave that until the end. Use the world origin as a reference for an axis of symmetry. Mark it with a construction line and extend it beyond the boundaries of the geometry. Now, we'll trace the outline using arcs and lines. These curve types are easier to dimension. Splines also work very well for tracing, but are a bit more difficult to control. Create a construction line normal to the axis of symmetry and tangent to the edge of the arc profile. This will help us define the nose or tail of the skateboard. Define the nose of the board by creating an arc using the 3-point arc tool. Place the beginning and end points first, and then adjust the arc by placing the middle point. Make one of the endpoints tangent to the construction line just created. This will help avoid a break in tangency when mirroring across the axis of symmetry. Create the middle line segment along the side of the skateboard deck. Extend the line past the location where it will intersect the missing arc. Use a tangent arc to connect the 2 existing curve segments. Then use Trim Away to eliminate the extra line segment that extends toward the nose. Draw a construction line to define the second axis of symmetry for the board. This line should be normal to the other axis and intersect it at the center of the board. Extend the straight line segment past this new construction line and use Trim Away to remove the excess piece. Go to the Design tab and click Mirror. Select the vertical axis of symmetry. Then click and drag a box around the curves that we've just drawn to mirror them. You can ignore any error messages that may appear. Click Select Mirror Plane again and select the horizontal axis of symmetry. Then, click and drag a box around the curves along the entire length of the board to mirror them across the horizontal axis. Once again, you can ignore any error messages that may appear. Return to 3D mode and hide the image from the structure tree. The sketched curves should now become a surface. Select the edges along the perimeter of the resulting surface by double-clicking and use Pull to extend the surface through the solid body. Make sure it passes through completely. Use Combine to cut the body using the surface. First, click the solid body as the target object, then click the surface as the cutter. Once the cut is completed, areas highlighted in pink by the mouse cursor can be eliminated by clicking them. Remove the excess material outside the surface boundary. Press S or Escape on the keyboard to exit the Combine tool. You can hide or delete the cutting surface from the structure tree. Add a radius of about 3 mm to the top and bottom edges along the board perimeter. Unhide the image from the structure tree and move it onto the bottom side of the body. Create a sketch plane on the bottom face of the skateboard. We're going to use Move Copy several times to recreate the holes. Sketch a circle on one of the holes. Remember that you can press and hold Shift to temporarily disable the Snap to Grid option. Use Move Copy to duplicate the hole and place it on the hole beside it. Try to use even values for the distances. Use Move Copy again on the 2 holes to replicate the 4-hole pattern. Use your best judgment when defining the spacing dimensions between the 4 holes. Now, select the entire pattern and use Move Copy to move it to the other side of the board. Once again, examine the spacing between the original set of holes and the new set and decide on a logical value for the distance. Now, hide the image and return to 3D mode. Click and drag a box around all 8 circular profiles. Then use the Pull tool to cut the holes out of the skateboard. Now, it's time to add the remaining components to complete the skateboard. First, use File Open to retrieve the file labeled truck.scdoc. Examine the model. Something looks a bit strange here. Note the transparent areas throughout the geometry. Transparency typically indicates an item is not solid. Occasionally, imported geometry may contain errors or be missing features. Fortunately, SpaceClaim has a wide array of tools that focus on repairing models. Expand the hanger component in the structure tree. Notice a collection of individual surfaces. Next, expand the base plate. Notice the item labeled solid with the purple icon. An item can have any name, but only a surface will have this icon. A true solid in SpaceClaim will have a green cube icon. Go to the Repair tab. This toolbar contains a wide variety of functions for fixing geometry problems. Click Missing Faces. Notice the report at the bottom of the window. It should indicate 28 missing faces and highlight areas all over the model. Let's pause here for a moment to discuss an important item. The tools in the Repair tab are designed to automatically locate and repair areas of the model fitting certain criteria, which typically indicates a problem, but they cannot know the intentions of the designer. As with any tool, they should not be applied haphazardly all at once. Take a moment to examine the model and understand the areas being highlighted each time you execute one of the repair commands. The current results are a perfect example of a situation where we need to use our intuition. We're being told there are 28 missing faces, and technically this is 100% accurate based on the criteria the Missing Faces tool uses. However, looking more closely, we can see very clearly that some of the areas highlighted appear to be in perfect condition. If we were to blindly accept these results, we would end up further complicating the model and creating a lot more work for ourselves. The key here is understanding why this result appears. Missing Faces seeks out closed perimeters with no adjacent faces attached. Since we have a collection of individual surfaces, these all qualify. The surfaces are not attached, so every edge loop with an opening is reported as a missing face. For missing faces to work properly, it's important to use Stitch first. Press Escape to exit the Missing Faces tool without changing the geometry. Click Stitch. Pay attention to the tool options on the left. Adjustments may be necessary for very large or very small models, or to avoid identifying areas by mistake. Click the check mark to accept the result. Click Missing Faces. Notice that openings like holes may be marked by mistake. Manually clicking individual items that are highlighted allows us to repair them one by one instead of accepting all of them at once. Click the outline of the rectangular face. Once the face has been filled, press Escape. We now have another problem. The new face covers the opening of the 4 holes. To fix this, go to the Design tab and click Split. Select the top face. Then, click the Select Cutter Face option indicated by the handsaw icon. Zoom in and select one of the cylindrical faces. The icon in the structure tree should now be a solid. Select the circular faces that were cut out and delete them. If necessary, select the solid in the structure tree. Then go to Display, Style Override, and click Transparent to disable that option. With neither Style Override option selected, the model appearance will return to the default for solid and surface display. Now, examine the hanger. Expand the component if necessary, and select the surface. Click Display, Style Override, and set the display style to opaque to get a better look at the model. You can also use Repair Missing Faces to highlight any areas that are open. Right-click Hanger and select Open Component. This will open the component in its own model window and allow us to focus on only this geometry. Any changes made here will automatically appear at the assembly level. Begin by repairing the small surface on the negative Y side of the model. We can now use Blend to connect the opposing long curved segments and use the short segments as guides. Use the Fill tool to cap the circular face at the end of the axle. The part should now be solid. The color of the individual face can be set from the Display tab. Now, close the design. Save the file and close the additional tabs. Use the Import option to add the repaired truck into the skateboard design. Use Assembly, File, to retrieve the repaired truck. Right-click on the component in the structure tree, then select Source, Use Internal Copy. This will break the connection to the external file and save the geometry in the main assembly. Use the Move tool to orient one of the new components into its approximate final position. The yellow bushings on each truck should face each other when assembled. Select the truck component and use Move Copy to create a duplicate. Use the Align assembly condition to make the bottom of the base plate coincident with the bottom of the board. Use Align again to create a coaxial condition between a hole on the base plate and the corresponding hole on the skateboard deck. Create one more align condition with a second hole on the base plate. The holes may not be a perfect fit since we did not use exact measurements to create them. You can always improve the model by filling the holes in the skateboard deck and using the holes in the base plate of the truck to cut out new ones. Repeat this process for the second truck component to assemble it to the skateboard deck. This concludes the exercise on creating geometry from a reference image.